working with XML data. So XML is pretty popular these days. We use it for virtually everything. It's a simple data format to consume. It's used for everything from configuration files to data sets to exchanging and sharing information across systems and even across platforms. So it makes sense that SQL Server has full-blown support for XML. And as a DBA, we need to know how to work with XML. We need to know the what, the whys, and the hows because there will be a day when a developer comes along and says, hey, I want to put some XML in your database, and you're going to need to help them get there. So in this nugget, we're going to answer those questions and see how to work with XML and SQL Server. So we'll start here with an overview where we'll just cover the what, the why, the how, and the where when it comes to XML. Then we'll jump into the virtual nugget lab. We'll start by just getting familiar with the XML data type and schemas because we can store both typed and untyped XML data inside of SQL Server. So we'll need to know how to work with both of those. Once we get familiar with the objects, we'll take a look at how to bring XML data in to our SQL Server objects, to our tables and our XML columns and such. Then we will also look at how to process XML data and really hear how to query it, how to filter it, how to modify it. And then at the end here, we'll look at how to shape XML data. Really, and how to shape relational data as XML, and then how to shape XML as relational data. So you'll get a good taste here of all the different areas of XML and how to work with it in SQL Server. Let's start with a little chat about why we would want to use XML and how we would store it in SQL Server. So the first question is always why. Why should we use XML in SQL Server? There's a lot of reasons for it, but essentially the big ones are going to be for interoperability with other systems or other vendors, and that's a very popular thing to do. You know, people will expose a web service that you can tap into where you'll transmit your XML to their web service for integration points. And I can tell you as a developer, I've done this quite a bit. And one of the things you always want to do in that scenario is anytime you send XML to somebody, you're going to want to take a copy of what you sent and put it somewhere so you have a footprint of what happened. So the bottom line there is it's good for interoperating at all levels. Internally between systems, externally between systems and vendors, and even across platforms because it's XML. Everything and everybody understands XML, so it's a good choice for interoperability. One of the bigger ones here, if you have the need to query or modify your XML data, SQL Server is perfect for it because it gives you a nice centralized place to put all your data. But on top of that, it makes it easy to search, sort, filter, modify, delete, do whatever you need to do with the XML inside of that document or fragment. Another one is SQL Server will automatically check the well-formedness of our data coming into an XML object. It just happens automatically, so that's nice. So if you need to do any sort of ensuring that your XML is well-formed or adheres to a specific structure in the form of a schema, which we can also do here, we can import a schema, tie it to, say, an XML object, and then it needs to adhere to that exact schema. So it's great for enforcing structure and validity. So, and by the way, typed XML is XML that's associated with the schema. Untyped XML is just free-form XML that has no associated schema. SQL Server has support for both of those. So we have a lot of reasons to store XML in SQL Server, but if you do have semi-structured data, store it along with your structured data. Then you have a centralized place for all your data. With the added benefits, of course, of querying, modifying, and enforcing validity. Some of the big things we're going to be doing with XML when it comes to SQL Server are importing it, bringing it in, exporting it, sending it out. And when we do either of those, we may need to take our relational data as it sits, model it as XML so we can export it to another system, or we may need to do the opposite. Take the XML that we're bringing in, shred it to relational data so we can store it and then work with it. Those are some popular things to do. And then also maybe we're just storing the raw XML itself so we can query and modify it as it sits. So those are going to be the big ones there. Importing, exporting, shaping it, storing it so we can query, modify, search it, and work with it. So when it comes time to actually store XML, how do we do it? What data types do we choose? Well, we do have an XML data type in SQL Server, but that doesn't always mean we should use it. In fact, you should only use the XML data type when you really are going to be working with the XML data. Querying, searching, filtering, sorting, modifying, all that kind of stuff. If you really need to work down at the data level inside of your XML, then you will want to use the XML data type. If, say, you just want to store documents, XML documents that are static, that you won't do much to them, or in the case of you're working with a vendor and you want to take the snapshot anytime you generate XML to send it, and you just want to store that snapshot of XML inside of your data, then you should use the LOB data types. And varchar max, for instance, is a great one. Use that. So if you're not going to do anything with the XML but store it, definitely use the LOB data type. Otherwise, if you still have static data that you're going to use, but you still want to make it searchable, then you can still use the XML data type and pop some indexes on it to make those searches extremely quick. Another really good example, and the one that we're going to use in our demonstrations here, is storing sparse data. Now, we looked at sparse columns in a previous nugget. And sparse columns are great. They're easy to work with and they're great, especially for existing structures. But what if you didn't want to manage an extra 50 to 100 or even more columns for all that sparse data? If you have the choice to design it from the get-go, an XML column would be a lot easier, as long as everybody knows how to work with XML, because it's one extra column. It's one column, and we could create a schema associated with it so we can ensure that the data and the structure is valid. But that will make it real easy on application developers and ourselves, because sparse columns, making a column set, makes it easy for application developers, but it doesn't make it easy for us because we still have lots of extra columns to manage. This way, we kind of get the best of both worlds. We make it easy for application developers. They only need to deal with one column, and they make it easy for us because we only have to manage one column. So I should have put that one over here on this list, but sparse data, that's a great way to use XML inside a SQL Server. And as I mentioned, that's what we're going to do in our demo. So in our demo, we're going to add to the learner table a learner info column. That's going to track just random miscellaneous information about our learner. Everything from their preferences to their favorite technologies to their current certifications. With that, I think it's about time we head into the Virtual Nugget Lab and do some work with XML and SQL Server. Welcome back to the Virtual Nugget Lab. Let's head into SQL Server Management Studio, where we have a new project, 08.xml. We've got some queries and scripts in here to work with. We've also got some XML to work with, and even a schema. So we're going to start here with storing XML. And really, I just want to get you familiar with typed and untyped XML, how to create a schema, how to create an XML column associated with that schema, and then we'll get into actually getting XML data loaded and then working with it. But first things first here, let me get you familiar with the XML. So it's pretty straightforward XML. It's going to contain learner info. We've got a link right in the XML so we know what learner we're working with. So we have a learner ID as an attribute. And then we have just a bunch of elements. One to track preferences, text, and certs, as you saw. So we've got XML here for learner ID 10, learner ID 100, and learner ID 1000. Varying levels and forms of XML in here to work with. And then we also have a schema, an XSD schema associated that we are going to associate with this XML when we create a typed column. And schemas are just there to define the structure of the XML. So data types, order, how many items you can have nested, that kind of thing. And I should also mention namespaces here. That was one of the objectives, to understand what namespaces are. Namespaces are there to help prevent naming collisions. So that way, if you have lots of XML that you're working with, or you're integrating with other XML or merging XML, you're not going to have naming collisions if both your XML coming from different areas have like an order element, because you can prefix your XML with a namespace. You define it in the top of your XML, give it a prefix, and then you can see here what XSDs do. They prefix everything with the XS namespace. That way it prevents naming collisions if any sort of merging were to take place or integrating with other systems. So there you go. That's what namespaces are all about. And that's what our XML looks like. So let's go ahead and work here first with untyped XML, where we're just literally going to create a variable of XML type, put some XML into it, and then output it here to the screen, just doing a select. There it is. Here's what XML looks like. And this is, again, untyped because we didn't associate it with a schema. So it's a very loose form of XML. All right, so that's it. Now let's go to the next level here and work with some typed XML. In order to do this, we're going to need to load that XSD, that schema, into SQL Server. So we need to get this data right here into SQL Server as a schema collection. And a lot of people just bring it in as a string, and that's easy enough to do. You can just declare it as a varchar, convert it to XML, store inside of that varchar your entire XSD, and then create the schema based on that variable. Since I already have this sitting inside of this XSD file, I'm going to use open row set here. We're going to get an open row set when we look at importing XML, because it's a great way to do it. But essentially what we're going to do here is just use open row set to load all the data in that file, store that into an XML variable, and then do a create XML schema collection, name the collection as that variable. So this is going to take it from that file, load all that XML inside of that XSD document there into this variable, and then we're just going to create a schema based on that variable. So let's do that. Boom, there it is. And now we can view it. Let me just show you how to view it here. Select everything from sys.xml underscore schema underscore collections, and there it is. So now we can see that our schema is in XML. And now if we want to create a column that's of an XML data type, we can associate it with the schema just by passing in the schema in parentheses after the XML data type. If you omitted this part right here, it would be an untyped XML column, and you could store anything inside of that XML column as long as it was well-formed XML. But by doing this, it not only needs to be well-formed, but any XML that goes into this column must adhere to our schema. So let's do this. Let's hit execute here. That will create the column. And now if we head into tables, our learner table columns, let's refresh it here. We should get a learner info column, XML, and then we can see the schema associated with it. So that's cool because now we have peace of mind knowing that any data that comes into this table must adhere to our standards. So now that we have an XML column out there, and we've got XML data on the file system, it's time to get some XML data into this column. So let's go into our importing underscore XML script here. And a couple of ways to import. Open row set is what we're going to use. One of the easier ways to get data here into SQL Server. Bulk insert is another one. We looked at bulk insert in a previous nugget. You can also use format files to do so. And I want to give honorable mention here to SSIS because personally I think that's the easiest way to import lots of data into SQL Server, especially if you have like a single document or a few documents with all that data in one document. It's much easier to use SSIS rather than any of these other techniques to get your XML into your SQL Server structures. So we're going to use open row set here along with the bulk option, which reads it from a file, along with the single blob option, which reads it as a single row, single column as a var binary max. You can also use single clob, which will read it as an ASCII file, varchar max, or single enclob, which reads it as Unicode data and varchar max. So by doing this, we can then convert. By the way, this is going to return, again, single row, single column. It's going to be called bulk column. In fact, I put it up here for reference. And then we can convert it to XML. We should get all of that data looking like this, just one big XML string. So here's the raw form, var binary, and here is the converted to XML form. And if you click on this, there is that data. So it's just pulling it all in from that file. So that will give it to us all in one shot. And now what we're going to do, because we have it the easy way here, just a separate file for each one. Again, if you do have one big honking file with all this in it, I would advise SSIS to make that process a breeze to get it into XML, or to get it into SQL Server. But we've got it, each one of these individually, which means we can just run an update statement right inside of the from clause with open row set. So we're going to update our learner, set learner info equal to that converted XML. Use open row set with bulk to read it from that file, and we'll update that where learner ID equals 10, 100, and then 1000. So let's do that. Boom, 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 all in, and now we can just select everything for those learner IDs, and look at that. All the way over here, we have our learner info XML column with all of our XML data inside of it. So now that we've got XML data loaded inside of our column, let's go take a look at how to work with it. So in our processing XML here, we've got really 4 big XML methods. And you need to get familiar with XPath here, which is actually really easy to do. But essentially we have query, value, nodes, exist, and modify. Those are all the methods that the XML data type supports. So you can see we're calling these methods right on our XML column. So let's go through all of these. Query and value first to query XML. Value is what you're going to use to extract specific pieces out of your XML so you can work with them inside a SQL Server. Query is more for pulling out chunks of XML, although there is a query method that you can use, or a text method that you could use here. We could do this, which will pull out and treat it just like value. But the thing is, when you're working with typed XML, that doesn't work. You can only do text here with untyped XML. I'll show you a better alternative here in the next couple of queries. So value is good for extracting specific information. And again, here you just need to learn a little bit of XPath, which is easy enough. In fact, if we open up Learner 10 here, we can see in order to get to our last nugget watched or favorite course or auto login, we need to go to Learner Info, Preferences, Last Nugget Watched. That's our path to get there. So if we look, that's all we're doing with value here. Learner Info, Preferences, Last Nugget Watched. That is going to be the first parameter. And we're also specifying to pull out the first instance, which is the only instance in this case, but you do need to pass in a singleton when working with value. And then you also, as a second parameter on the value method here, specify the data type. So this will pull out the last nugget, this will pull out the favorite course, this will pull out auto login. And then we're going to use the query method to pull out the course requests XML chunk. Now, if you look your course request, we can have many children under the course request element. So that's going to take a little bit of a special programming to get that to work. So we'll talk about that. But for now, we're just going to pull out that whole XML chunk. And then you can also see we can use query and value together. So we're going to use query to get down to the request level. And then we're going to use value with the dot here. We're just referencing it relative here, saying give us that value and convert it. So that's the way around using our text method to pull it out here when dealing with typed XML. You can query to that object and then just do a value, pass in a period, convert it to your data type. And then we'll do the same thing with micronugget requests there. So let's do that. Let's highlight this whole thing and look at that. So we're pulling out the actual data piece by piece. So last nugget, favorite course, auto login, and then here is our XML for the course request that we use the query method to pull out just that specific XML there. And then we use course request 1. Here is where we're using query and value together to extract the first request. And then same with micronuggets. And you can see they've only got one request here anyway, how to win the lottery, but that's the one we pull out. So that's query and value, good for working with specific pieces of XML. The nodes method is good for, in this scenario, let's say we wanted to pull out all the course requests, not just the first one, or you didn't want to work with the ordinal here using a singleton, because that would be a lot of code if we had a dynamic number of requests, which we do in this case. Some people could request 1 or 2 courses, somebody could request 100 courses. So when you don't know exactly how many requests we can have, we need it to be dynamic, right? So we can just pull out all the requests. And that's what nodes is good for. With nodes, along with cross-apply, we can shred the XML and get exactly how many are there. So that's all we're doing here, is we're grabbing the first name, last name out of our learner table. And here we're doing an L.value, so we can extract the actual value of their favorite technology. And then cross-apply to nodes. Cross-apply along with our nodes function or method is actually going to do the shredding. So we're saying just give us all the technology, all their favorite text, and output it as column favorite text. So if we do this, we're going to get a row per tech along with the learner associated with that tech. So you can see Luz Han here has 3 favorite texts, Regina Duffy has 4 favorite texts, and Clifford Bullard has 2 favorite texts. So we can see learner 100 here should have 4 favorite texts. If we open them up, there are all 4 of them. So nodes is a great way to do that, to actually shred the XML so we can work with it inside a SQL Server. Useful for, again, when you have a dynamic number of child elements. Moving on here, exist is good for checking for the existence of things. In fact, if we wanted to check to see how many users had micronugget requests, then we could just do an exist, pass in our path to the request node down there, all the children nodes of the micronugget request node element, hit execute. And right now, everybody has micronugget requests. All 3 of our learners have micronugget requests in here. So what we'll do is when we get into modifying next here, I'll show you how we can modify it to remove all of these requests. And then we'll rerun this query, and we should be down to 2. So that's all exist is, just good for checking the existence of things. Modify is how we're going to modify that XML data. And there's a couple of ways to use it. We can use it to replace values, to update existing data, or we can use it to delete data or elements out of our XML. So first off, let's take Learner 10 here, and let's look at Learner 10's XML. So Learner 10's XML for their first request here is 70-464, the one we're looking at. That's a request. Developing SQL Server 2012. So that's a request. So what we're going to do here is take that request. We're going to actually modify the XML data that's in this file, in this request right here, And we're going to do that by using the modify method along with a little X path here of replace value of. The syntax is really easy here. Replace value of, then our path, with, and then our value. So you can imagine writing dynamic SQL to make all this happen would be pretty straightforward, right? And you can create some pretty dynamic applications and easily allow a developer to just call a stored procedure, pass in their parameters for what these values are, and then we can just write some XPath to make all this happen. And that's really the ultimate goal, right? When you're dealing with, say, an XML sparse column that has all this data, you want to make it easy for your developers or anybody that's going to be working with this with this data to modify it or delete it or remove it or add to it. And so that's what we're going to use this modify method to do. But let's do that. Let's go ahead and run this. We're going to modify some XML. And why am I going to this file? We didn't modify the data in the file. We modified the data inside of SQL Server. So let's run our first query again here. And what do we get? We should see that our first request now for learner number 10 is no longer 70-464. It's how to build a spaceship. Wouldn't that be quite the request? All right, so let's scroll down here. And the next thing I want to show you here is how to delete. How to delete. So now we're going to take learner 100 here, and we're going to delete their micronugget requests. That way we can see when we requery using the exist that it should no longer be there. So let's just do one more test here, just to make sure that we get all three back. We do, because their micronugget requests in the database are still, for learner number 100 here, is there we go. SQL Server 2014 new features and Hadoop 2.0 new features. All right, so back to our data. Delete is really easy. Literally just pass in delete along with the path that you want to delete. And that's it. Hit execute. There it is. Now we can go back to our exists, and we should only get 2 records now. And we do. And that's because if we look back by running our first query here, and we look at number 100. Oh, did I look at the wrong one there? I did. We want micronugget requests, don't we? There we go. Look at that. It's empty. And you can see that right here in this column that the micronugget requests are gone. Piece of cake, right? Easy to work with XML and SQL Server. You're just going to rely on these methods on the XML data type, which allows us to do everything we would ever need to do with our XML data. Let's move on to our last area here, which is shaping XML. The time will come, if you're working with XML, you're storing XML, where you're going to need to take your XML data and turn it into relational data. And vice versa. The time will come when you need to take your relational data and turn it into XML so you can export it and give it to somebody else to use. So let's start with the first one, taking our XML data, transforming it to relational data. And I'm actually going to show you how to use a join here. We're going to take our data that's stored inside of our columns, join it to other relational tables, and then you'll see our output here. So we're actually going to bring our XML and our relational data together. So we're going to declare an XML variable here of XML data type. We're also going to need hdoc, which is going to just be a handle to the actual XML itself. Because in order to work with OpenXML, you need to execute the stored procedure spxml prepare document. So the first thing we're going to do is just get our XML for learner ID 10, stuff it into that variable. Then we're going to prepare the document by getting a handle to that XML, and we get that using the output parameter on that hdoc variable, and then passing our XML as input to this document. Once that's all set, we can start working with the XML data, load it up, work with it, join it to other relational tables and such. So then we're just going to select everything we want to select, both from the XML document and from our relational, from our tables. We're going to do a from OpenXML, pass in our handle that we got from the output of our prepared document, and then also pass in the root node that we're working with. So we're going to pass in learner info, that's the root node. Then we're going to do a with, and we're going to define our XML columns and where they're coming from. We start with learner ID, so we're really just defining our columns here, right? We're defining our columns and how we're going to be able to access them using T-SQL relationally. So learner ID is an attribute off of learner info, which it is, so that's all we're doing here. Last nugget watched and favorite course are both nestled under preferences, so we're just building our path once again. Learner info, preferences, last nugget watched, learner info, preferences, favorite course. And then our texts here are also going to be stored as a descendant of learner info. So that's all we're doing here. So by doing that with the with statement, we're opening this up to being able to access it from SQL, which is what we're doing down here then, is we're joining the course table based on the favorite course to the course ID of our actual course table. Same with nugget then, and we're good. And then we just call spxml remove document, pass in our handle. That way it will unload that document from SQL Server's memory. That's it. Now we hit execute, And check it out. We get all that data in relational form. Cool, huh? So OpenRoset's a great, easy way to model our XML data as relational data. The next one then is for XML, which is what we're going to use to do the opposite of that. Model our relational data as XML. And for XML has a lot of switches on it. We have auto, elements, raw, and path. I'm going to show you the big ones here, which is going to be auto, elements, and then I'll show you how to really shape your XML the exact way you want it to using path. So XML auto looks just like this. If we say give us, let's say we want to model courses, that's kind of what we're doing here. But let's say give us everything from our courses and our trainer table tied together for XML auto. That's going to create everything as attributes. So there's all of our courses and our trainers associated with those courses, all as attributes. So obviously that's not ideal. So sure, we could say give us a mix of both, or give us elements rather than attributes. So we could say auto, comma, elements, and watch this. It'll look a little bit better, but now we got the opposite problem. Everything's elements, when really our IDs should be attributes. That's a good best practice when it comes to XML. It makes it a little more readable and understandable and shaped a little more like the data we want to see. So the best and easiest way, I think, even though this is easy, but I think the best, clearest way to do this is using path. So using path allows us to alias our outgoing data in the way we want it to shape. It's really cool. So course ID, we're saying we want it to be an attribute. Title is going to be an element. Description is going to be an element. Nuggets and duration are going to be elements. And then we got some trainer info that we're going to model as well. Only this time we want trainer to go under its own element. So we're saying create a trainer element, put the trainer ID as an attribute on that element, and then have first and last name as children under the trainer element. Also with path, you can define what you want your enclosing element to be named. So all of this is going to be wrapped inside of a course element, and then the root is going to be called courses. And watch this. This is really cool. And you can see what little T-SQL we have to shape this the way we want it to. So here's what it looked like. Doesn't that look a lot better? So now we have courses along with courses are the root. Then each course is an actual course. Our IDs are now attributes. We have some course information. Then trainer is its own element with children element describing the trainers for that course. So this is cool and pretty much ready to go. If we wanted to share this with a vendor or anybody else that wanted to consume our courses, we could easily ship this off and now they have access to all of our data. So that is an awesome way to use for XML. In this CBT Nugget, we learned how to work with XML data. We started off with an overview to get familiar with the scenarios that would be a good fit for storing data in SQL Server and the kinds of things that we would do with that data. We jumped into the virtual Nugget Lab. We've got a lot of demos with how to work with XML data. We saw how to use the XML data type, how to associate a schema with an XML column. We saw how to load or import XML data using OpenRoset. We saw how to search and filter and work with XML data individually by using the methods on the XML data type. And at the end, we saw how to shape XML as relational data using OpenXML, and also how to shape relational data as XML using for XML. I hope this has been informative for you, and I'd like to thank you for viewing.